Hello, today's lesson is not really anything new. What's exciting though is that we're going to finally be able to use sine and cosine to talk about real life situations. So we're going to be fitting equations of graphs to these curves. Sometimes they'll give you the picture, sometimes they won't, but in this first example they give us the picture. It looks like it's sort of starting in the middle here and then going down and coming up, and it's finished with its full cycle by the time it gets to 6. So since it started in the middle, I'm thinking that that looks like a sine curve. And then for each of these, I'm just going to have us figure out our amplitude, our period, and our vertical shift. So on this one, we just talked about how I did it down and then up, and it was finished by the time I got to the number 6. It looks like it goes 1.5 below, 1.5 above, so 1.5, and that midline is still right at the 0. So from that, we're going to try to write our equation. Remember the period for sine is 2 pi over b, and we want our 2 pi divided by whatever b is to equal 6. You could call that 6 over 1 and cross multiply. If you divide by 6 and you reduce, we're going to get our b equal to pi over 3. So I think that's enough to write our equation. So we've got y equals, the amplitude is 1.5 sine of our b value times x plus 0 if you want. And that's the equation that would fit that curve. So we're going to actually apply this to, for example, a temperature situation. So this is actually talking about a year, months since January. It's talking about high temperatures and low temperatures. And look at that. Apparently, in January, that's when we had our high temperature going on. Low temperature in June. High temperature again 12 months after January, which is January again. So I'm thinking southern hemisphere. But we're going to try to write an equation for this. So I'm going to try to draw this thing in. Remember this thing? There's our max. There's our min. The max is at 79, it says. The min is at 66. Can you figure out where that midline is? The way I like to do this is I like to find the average of 79 and 66. So I add them together, divide by 2, and that average winds up being 72.5. So that midline must be at 72.5. So from there, can we write down amplitude, period, and vertical shift? So amplitude. We need to go up and down from the 72.5, and it looks like that would be 6.5, right? Up 6.5, subtract 6.5. The period is 1 year, so since we're measuring our time in months, let's call the period 12. And our vertical shift is just wherever the midline is, which we figured out just by averaging the max and the min. I'm thinking this looks like a cosine graph since it's starting at the very top, not at the midline. Had it been at the midline, I would have thought sine, but it starts at the top, so cosine. So here we go. Y equals, or I guess maybe I should have put temperature equals. The amplitude is 6.5. We decided on cosine plus 72.5. Wow. And we need to decide what to put next to our x value, or I guess we could use a t value this time, but cosine is also 2 pi over b. We decided we wanted the period to be 12. Call that 12 over 1. You can cross multiply to solve. And if I divide by 12 and reduce, I'm getting pi over 6. So that would be an equation that could tell us the temperature this many months after January. So when they give me some information where it just gives us some points. I like to draw it because, I don't know, I'm way too visual to even understand what that is. So 0, 2 is 1 point. 4, -4 is my minimum point. So if this is the max and that's the min, this sort of to me looks like a cosine function, but they didn't finish it off, so it would have to come back up and be up there, and then maybe it would look cosine-y. So if this is at 4, it's going to take just as long for it to go back up. So I'm thinking the period would be 8. Let's check this out. So we're up at 2 for the top. We're down at -4 for the bottom. And what's halfway between 2 and -4? If you like doing my little average way, you can go 2 plus -4 divided by 2. And you get -1. So that just tells us that our midline is at -1. Our vertical shift is -1. And from there we go up 3, and down 3 from the dotted line. The amplitude is 3. The period. I was thinking cosine since it started at the top, so 2 pi over b needs to equal 8. Cross multiply that. Two pi over 8, pi over 4. So really, if you can get every problem into a picture, it's not going to be that bad. Let's try to picture this one. The height in a bay varies sinusoidally. Oh my goodness. That just means it has the curve of a sine or a cosine. On a certain day, a high tide of 11 feet occurred at midnight. And I suppose we could just have, time is going to be in hours since midnight. So we'll just pretend at 0 that means midnight. And it was up at 11 feet. And the low tide was 2 feet at 6 a.m. That's 6 hours later. I had to look this up because I don't get out enough, but so by noon it would have been at high tide again. So I looked this up, and apparently there's 2 high tides per day and 2 low tides per day. And so there's from midnight to noon. That's what we're looking at. Like I said, if you can get that drawn, we're going to be fine, because then we just have to come up with the same info every time. What's halfway between 11 and 2? Well, the average of 11 and 2 would be 13 divided by 2, so 6.5. So our vertical shift is up 6.5. From there, we're going to go up and down from that dotted line. Another 6.5. No. Wow, math, hard. 4.5. And then the period is 12 hours. And since we start at the top, I'm going to go cosine. Y equals 4.5 cosine. X stands for hours since midnight. Okay, maybe I should have used a T, whatever. And then we just have to figure out what our value of B is every single time, you guys. It's always a sine or cosine curve. 2 pi over B equals the period. Solve that for B. This time it's going to be pi over 6. So then you can plug in any time of day and you'll know what the height in the bay is. That's useful. Ferris wheel problems. I have to draw the Ferris wheel in order to picture this. So, Ferris wheel, round on some sort of stand of some sort. It says that this Ferris wheel has a radius of 42 feet. And I think we're going to be talking about the height, so I'm going to put the 42 there. And here'd be another 42. And when t equals 0, we're starting at 87 feet above the ground. So when we're at the lowest point, it'd be 87 minus this diameter, so minus 84. So we'd be 3 feet in the air when we're at the bottom. And it's going around 2 times every minute. So let's see if we can draw this. It says we're starting at the top. So we're going to start up at 87. We're going to come down to our lowest point of 3. And we're going to go back up. And because it's a circular Ferris wheel, it's going to have a sinusoidal curve to it. In this case, it's a cosine curve. There's no such thing as the word cosinusoidal. So sinusoidal just means it's either sine or cosine. Oh, and then it goes around twice every minute. So that means it's going to go around once every 30 seconds. So start at the top, get back to the top in 30 seconds. Be at the halfway point at 15 seconds. So we'd be down at the bottom at 15 seconds, back to the top. There we go. 87 plus 3 divided by 2, 45. And then up and down from there is, 42, right? Because it's up 42, down 42. So we've got an amplitude. Our period is 30 seconds. Our vertical shift is at 45 feet, which I think, doesn't that just represent where the center of the Ferris wheel is? And we start at the top, so I'm going to call that a cosine graph. .30 is our period this time. What would B have to be? Pi over 15. And there we go. I want you guys just to give the last one a try. So if you could just pause me, work together, see if you could come up with it, and I'll give you the answer. Here's what my graph looked like. Started at 4, went up to 34. So it's kind of a flipped over cosine graph. I called this 0.2 because it was 5 times a minute, so 0.2 minutes. Oh, they want it in seconds. So what's a fifth of a minute? Is that 12 seconds? We'll call that 12. All right. I wound up with this. Since it was reflected, did you get the negative in there? Negative 15 cosine. We had to shift it up 19. And then 2 pi over b had to equal 12. So I think b is going to be pi over 6 again, right? 12 seconds per revolution. We fit in 5 in a minute. Yeah. That's what we're looking for.